Okay, so today I'm going to show you how to graph the derivative function in your TI-84 Plus. There will be two ways of doing that. So I have here two functions for us to graph the derivatives of. So let's take a look at function number 1. So I'm going to write that down into my y1. So I'll have x cubed plus 7x minus 11, and I graph that, and I will be able to see that if I fix my window properly, perhaps adjust it. So let's try negative 50. Okay, so perhaps that's a good enough graph of the original function. So y2, so the first way is going to be graphing it manually by finding the derivative. So the derivative of this function is going to be 3x squared plus 7. Okay, so we graph that simultaneously. It's somewhere up there, so let's just change our window, adjust it so that we could see that derivative function. Okay, so the red curve which is quadratic is our derivative function. The second way is using our calculator to do it for us without manually finding the derivative algebraically. Okay, so I'm going to use the derivative function from math, and then I press number 8. I'm going to use variable x here because I intend to use y1 to be the function that I want to differentiate. So I'm going to press alpha f4 y1. Okay, and then I'm going to say that I'm going to differentiate that for x values equal to all the x values in the domain that's possible in here. Okay, so when I graph that, y3 should be tracing the curve for y2. Okay, so that's two ways of graphing your derivative function. Most of you will be comfortable with just finding the derivative and graphing that manually, but you might be given a function that you cannot differentiate manually in IB, SL, or HL applications. So you will have to be forced to use the second method to find the derivative. So let's take a look at question 2. So I'm going to write question 2 in y4. So 2 to the x plus x squared. Okay, so SL or HL applications are not required to know the derivative of an exponential function. It's just the natural exponential function that we differentiate, not an exponential function in general. Okay, so I will not be able to differentiate this. For me to graph the derivative function, I will have to use that. If I have that on y3, I could actually just change y1 into y4. So I'll go ahead and do that, y4, so that the original graph and the new graph will be seen. Okay, so the black one is y3. That's the graph of the pink one is the function, the exponential function, and the derivative function is the black one, the derivative of y4.